Austin American Technology is pleased to present Are You Cheating on Your Cleaning? Well, Inspector Clouseau sees a problem here. Do you see a problem here? Are you cheating on your cleaning? Now, if your cleaning process is leaving flux underneath your components, then you're cheating on your cleaning. There are two reasons why we cheat. First, I didn't know I was cheating. I am meeting the IPC high reliability cleaning standards. Second, I knew there was some flux underneath the components. However, I didn't think it would be a problem. Now we're going to talk about how we cheat. Well, the IPC standards do not require you to look underneath the components. So visually you inspect the surface of the boards and they're perfectly clean. There's no visible flux residues on the board topically. However, if you were to inspect underneath the components, there would be flux residues left behind. Now, the IPC allows for hidden residues because it's virtually impossible to inspect underneath the parts, especially in a production environment. You'd have hundreds of capacitors and BGAs, and there's no way to visually inspect underneath the parts. But cheating has consequences. It causes burn-in failures, warranty failures, probe buildup and test failures. And if you're using a water-soluble flux or an organic acid, it's very important not to leave those residues left behind. If you manufacture a high-frequency product, it's also very important to remove all the flux residues on those products as well. So, what do? Now, the key to cleaning underneath your parts is using a certified tight gap cleaning process, which we'll go over now. So you ask, what is a certified tight gap cleaning process? Well, one, it's designed to clean tight gaps to start with. Now, most of today's cleaners are not designed to clean 100% of the flux out of 100% of the components from underneath the parts. Secondly, it has to be proven to clean those tight gap components. And lastly, it has to be controlled with limits to ensure that you're always cleaning the tightest gap components from every part on every board every day in a production environment. Now, every process has its limits based on science. With cleaning, there are four important factors. There's time, how much time am I exposed to the wash chemistry, the temperature of that chemistry, the concentration, am I running at 10% or am I running at 15%, and then there's the energy or the fluid delivery system. Now, which one is the most important? Time, temperature, concentration? Well, if you guessed energy, you are correct. Now, this is a Bernoulli equation, which is really covering how much energy is needed to get flow in a tight gap. The more energy, the more flow. You really need high impingement pressure to get fully filled gaps of flux to get the fluid flow necessary to remove that. Now, if your cleaning process lacks sufficient cleaning energy, no physical cleaning occurs in those gaps. So when we talk about energy, there are different fluid delivery systems or different type of nozzle or jet technology. Now in this glass slide study, we're looking at a fully filled gap of flux and we're using a flooding nozzle. Now you will see that there's absolutely nothing happening underneath the component. We're just getting a little bit of erosion on the outside of the component, but nothing's getting underneath there. So the exposed surfaces are clean, but nothing underneath the parts. Now what we're looking at here in this glass slide study is a coherent jet on the left and a fan jet on the right. Now the coherent jet, which has much higher impingement pressure, as you can actually see, is pretty rapidly removing the flux from underneath there. Now on the right, with the fan spray, there just isn't enough energy, so it's very slowly eroding the flux, and eventually, it might get all of it. Now if you look on the left, we've actually now just about completely removed all the flux. The one in the coherent jet is done, and the traditional fan jet is still running, and will be running for quite some time before you would see any more significant erosion of the flux underneath. Now we have shown you three different types of technology: the flooding jet, the coherent jet, and the fan jet. Now this is again showing you the speed at which a high energy jet or coherent jet can fully remove 100% of the flux out of a fully filled 3 mil gap. If you want to ensure full flux removal from all your tight gaps, from all your parts, from all your boards, and you want to stop cheating on your cleaning, call Austin American Technology today.